All right, so I'm only going to go over a couple of questions on this Jeopardy because these questions kind of go through all the different types that you might see and all the different ways to solve it. If you need help with any of the other questions, please just reach out. But these are the only questions that I'm going to go through in this video. All right, so the first question is the multi-step equation $600 question, and we have 3x plus 5 is equal to 2 times x plus 7. So remember, the first thing that we always need to do is we need to simplify everything that we can on both sides of our equation. Well, on this left-hand side, there's nothing for us to simplify. There's no like terms. There's no distribution. But on the right-hand side, we have the parentheses, which means that we need to distribute the 2 in. So we need to multiply. So I'm now going to have 3x plus 5 is equal to 2 times x, which is 2x. And don't forget, we need to also distribute it to that second term. And 2 times 7 gives me 14. Once we do this, we see that there's nothing else that we can do as far as simplifying on either side of the equation. So now we need to go ahead and start isolating our variable. And to do that, when we have variables on both sides of our equation, we need to move all of our variables to one side. So to move this positive 2x, or adding the 2x, I'm going to now subtract the 2x on both sides. And 3x minus 2x is going to just give me x. So now I have x plus 5 is equal to 14. Once we isolate that variable, then we need to move all of our constants to the other side of the equation and get rid of any multiplication or division that might be done to our variable as well. Well, since it's plus 5, we will then subtract 5 from both sides, and now we get x is equal to 9, and that will be our final answer. All right, the next question we're doing is the $800 multi-step equations. So in this one, we have two fractions that are equal to each other. We have 3 over 5 is equal to 15 over 2x minus 3. And when we have two fractions that are equal, this is called a proportion. And remember, the way that we solve our proportions is through cross multiplying. All right, so we will then take our one numerator and multiply by the opposite denominator. So now we get 3. And since this is a binomial, we need to make sure that we're writing it in parentheses like this because everything needs to be multiplied by that 3. The 2x and the minus 3 does as well. And then we will multiply the other numerator with the other denominator. So now we will get 5 times 15. And now we'll go ahead and actually multiply. We'll simplify. So we get 3 times 2x, which is 6x, and 3 times negative 3, which is minus 9. And 5 times 15 is then going to give me 75. And once I do this, I'm now going to have just a regular multi-step equation that we know how to solve. And we now see that we have multiplying and subtraction that are being done to our variable. We need to get rid of the subtraction first. We know the inverse of subtraction is addition. So I'll add 9 to both sides. So now 6x is equal to 84. And then to get rid of our multiplication, we need to divide each side by 6. So now I get x is then equal to, this would then be 14. So x is then equal to 14 is our final answer. And if we want to, we can plug it back in to check to see if this works. All right, so for this $1,000 question, I wanted to go over this one because I wanted to make sure that we're not confusing this answer with a special case. So let's go ahead and solve this. So remember, first thing we always do is we need to simplify. Well, on both sides of these equations, we actually have to distribute and simplify. So we get 2 times negative 6m, which is then negative 12m, and 2 times negative 3, which is then minus 6, is equal to 6 times 5m, which is 30m, and 6 times negative 1, which is then equal to negative 6. Now that we've done simplifying, I'm going to move all of my variables to one side. So I'm going to move my variables to the left. So to do that, I'll subtract 30m from both sides. So now I get negative 42m minus 6 is equal to negative 6. So now we need to start isolating that variable. And to do that, we need to get rid of our subtraction first. So to do that, we add. So when I add 6 to both sides, though, negative 6 plus 6 in both of these cases cancel out to give me 0. So now I have negative 42m is equal to 0. Or we don't have to write plus 0 for this negative 42m because anything plus 0 is just itself anyway. So we just need to make sure, though, that we set it equal to 0 because negative 6 plus 6 is 0. So we still have to have it equal to 0 on the other side. And this is where some people are getting confused. They stop here and they're not sure what to do. And because something zeroed out, they're like, oh, this must be a special case. No, it is negative 42 times m. We still need to isolate that m. And to do that, we would divide because it's being multiplied. So when we divide here, that cancels out. And now we're left with just our m. And 0 divided by any number is always 0. So our answer here is m is equal to 0. All right, so don't confuse this with a special case or anything like that. All right, 2 more questions and then we'll be done with this video. All right, first thing we always do is simplify what we can. There's nothing to distribute, but there are like terms in both of my sides of my equation, so I must simplify by combining my like terms. And negative 8x minus x is going to give me negative 9x. So now I'm left with negative 9x plus 5 is equal to, well, negative 6x minus 3x is negative 9x as well. So now it's negative 9x plus 5. This should hopefully jump out at you now. But just like we always do, when we have variables on both sides, we're going to move them to one side. So I'm going to move my variable to the left-hand side. But when I do this, since my variable was identical on both sides, they're both going to cancel and give me 0. So that means my variable completely eliminates. So it now gives me a statement of 5 is equal to 5. So we need to ask ourselves, is this a true or a false statement? And since this is true, that means that our answer is infinitely many or all real numbers. And remember, if you wanted to abbreviate to all real numbers, you can put the symbol for our real number system, which looks like this. And that would also be an acceptable answer. All right, so remember, your answer is not true or false. That's not what is the answer. That's what guides us to the answer. So once our variables eliminate, we need to see, okay, well, does what we have left over equal or actually give us a true statement? If it does, that means any number that we plug in will work. Because once we get to here, this should make sense to you. Any number we substitute in for x, they'll both be being multiplied by negative 9, so they'll still be equal after that. And then we'll be adding 5 to both of them as well. So once again, after we multiply and add, we will still be equal anyway. Okay, same thing as we always do. We're going to simplify each side of these equations. So I'm actually going to just go ahead and draw this line going down here because I was showing you this before, that you can help you to make sure that you're not doing inverse operations when you shouldn't be. But we have this parenthesis, so I know I'm going to distribute this in first. So 3 times 2x is 6x, and 3 times negative 5 is minus 15, plus 12 is equal to. Well, now I see I have like terms, so I'm going to go ahead and combine those. So now I have 6x, well, negative 15 plus 12 is minus 3. So now I have 6x minus 3 is equal to. All right, let me go ahead and simplify the other side. So this one, there's nothing for us to do besides combining like terms. So we will do 4x plus 2x, which gives me 6x, and negative 8 plus 11, which then gives me plus 3. So now this right-hand side is 6x plus 3. Once again, by now you should know what this answer is going to be, but let's go ahead. We have variables on both sides, so we'll move our variable to the left. Once again, when I do this, they're both going to eliminate and cancel, and now I'm left with the statement of negative 3 is equal to 3. And we know that that is a false statement. That is not true. Negative 3 does not equal 3, so that tells us that there is no solution, that no number that we substitute in for x can work for this, so there is no solution to this problem. All right, that is it for this video. If you need help with any other questions, please reach out.